Hello everyone, and welcome back to our SecurityX course. In this lesson, we'll cover key areas, including malware analysis, reverse engineering, threat response, root cause analysis, and more. Let's start by talking about malware analysis. This process allows us to dissect malicious software to understand its behavior, origin, and potential impact. There are two primary approaches to malware analysis: static and dynamic. In static analysis, we examine the code without running it, focusing on elements like file headers, embedded strings, and instructions. This helps us identify key characteristics of the malware. On the other hand, dynamic analysis involves running the malware in a controlled environment, such as a sandbox, to observe how it behaves in real time, like monitoring its communication patterns or payload delivery methods. Next, let's explore reverse engineering. This process involves deconstructing software, systems, or files to understand their inner workings. In cybersecurity, reverse engineering is often applied to malware or exploit code. By using tools like disassemblers and debuggers, we can uncover hidden functionalities, backdoors, or encryption methods within the malware. Threat response. Threat response involves three key steps: containment, eradication, and recovery. Containment focuses on isolating affected systems to prevent the threat from spreading. Once contained, we move on to eradication, where we remove the malicious code and close any vulnerabilities that were exploited. Finally, during recovery, we restore operations, apply necessary patches, and verify system integrity to ensure the threat is completely neutralized. Now, let's talk about preparedness exercises, which are a proactive way to test and improve our incident response capabilities. Exercises such as tabletop simulations, red team, blue team exercises, and full-scale simulations are designed to mimic real-world scenarios. For example, a red team might simulate an attack while the blue team defends against it, helping to identify gaps in defenses and improve coordination. When analyzing incidents, reconstructing the sequence of events is critical, which brings us to timeline reconstruction. This process involves piecing together logs, artifacts, and timestamps to create a clear picture of how the incident unfolded. It helps us identify the initial point of compromise, track the attacker's actions, and understand the full scope of the incident. But understanding what happened isn't enough. We also need to know why it happened. That's where root cause analysis comes in. Root cause analysis digs deep to uncover the underlying issues that enabled the incident to occur. It's about addressing the root problem, not just the symptoms. For example, if a phishing attack led to a breach, root cause analysis might reveal that inadequate employee training or a lack of multi-factor authentication contributed to the incident. Lastly, let's address insider threats, a category of risk that often goes unnoticed. Insider threats can come from malicious actors within the organization, negligent employees, or compromised accounts. Regardless of the source, they pose a serious risk to data security. Mitigating insider threats involves enforcing the principle of least privilege, monitoring user behavior for anomalies, and conducting regular security training to raise awareness. In conclusion, incident response is more than just reacting to threats. It's about being prepared, proactive, and thorough in every aspect. Thank you for joining us today, and see you soon.